I will focus more on cancer and adjuvants and how the adjuvants impact the CD4, CD8, and the B-cell responses. And that's what I would like to talk about this time. And again, the same slide, I will go over it in detail, but again, the conflict of interest, again, the reminder that depending on the diverse assays, what you use, and the readout. We discussed this already. And the approaches, here is just one more example. If you compare responses, that the accuracy of frequency measurements is the same as proper responses are used for intracellular cytokine staining and ELISpot. And here I show that, oh, where is the pointer? It was here, here. Here I show, this is the spontaneous interferon gamma intracellular responses. You see the 1.4% positive cells. The antigen-specific induced one is 21.1%. And then the difference is 19.7% of the cells, which produces an antigen-specific response. If you do that by ELISpot and you measure the frequency, it's 19.2%. So the two assays have the same precision and same specificity, but different sensitivities. Again, this is a validation point, proving again that cellular immune responses, yes, are very accurate and precise. Do I speak loud enough because in the back that you hear me? Yeah, okay. If it's not, just put up your hands and I will go back again and go closer to the microphone again, okay? We talked about ELISpot, and I assumed everybody knows what ELISpot is about. In case it's not, please apologize that I bring up the basic slide, how and the basics of what ELISpot assay technology is about and why the sensitivity and specificity is different. Okay, first of all, you start with the antibody of the released product of your interest. If it's a B-cell ELISpot, then it is, of course, the antigen of your interest, okay? Then you add the cells on top of it. Once the cells are activated towards your specific antigen, yes, which means any of the vaccine products, proteins, vectors, anything specific which you induce to the cells and which are to your individual assays and treatments and vaccine specifics, then the cells, if they saw it and the vaccine induced an immune response, produce the product and release it. The released product is captured. For T cells, the released product might be interferon gamma, IL-2, IL-4, IL-10, IL-17, whatever it is. For B cells, it's an immune globulin, yes? And that is then captured. It is plate bound with that one. It has no time to get taken up by other cells, absorbed, diluted in the supernatant, etc. And this is the main point why the increased sensitivity is there. Then you wash away the cells. In UV assay, ELISpot assays here, you do not need to wash the cells away. And then you actually visualizes that, and then this is how that looks like. I don't know, visually appearance, depending on which substrate you use. You can, every dot represents one cell's product, and the size of the dot represents the amount produced per cell. So you clearly can count then the dots, and that represents the frequency of responses in, say, if you plate 1 million cells, 1 out of 1 million, or if you plate 300 to 400,000 cells, then 1 out of 400. UV assays like that. Examples will be shown to you throughout. And now we talked about that. I will not repeat it. And now I want to focus on the adjuvants, because all of you work with adjuvants or diluents, yes? And any liquid you put your product in is an adjuvant. It might be a not so good adjuvant or a very good adjuvant, okay? PBS2, it's a carrier protein. It has consequences, whatever you used it in. So the adjuvants are substances which enhance immune responses. All of you are familiar with that, so I might not need to go into that detail of this, and I rather go and skip that. However, when we look at classical adjuvants and what is known in the literature, aluminum, CFA, IFA, and soluble means just PBS, and you look at proliferation responses, all of them seem to work the same, okay? Classically, that's what we have learned. All adjuvants, it seems to be independent what you use. They have, okay, the magnitude of the responses in proliferation is a little bit different, but all of them produce responses to the antigens of source. So for this reason, PBS, it doesn't work in some, but in others, depending on the route, even there you could induce some responses in proliferation. So for these reasons, it seems to be people are not really looking into too much detail what the adjuvant consequences are on CD4 and CD8 T cell responses. And as we discussed before, the primary readout in 90% of the cases is total IgG response measurement. And if you do that, the total IgG response measurement is the same, okay? They all give good immune globulin responses. It's fine. If you look at the subclasses, however, then suddenly certain surprises seem to come up, as different adjuvants induce different subclasses. Like CFA induces IgG1 as well as IgG2A, IFA IgG1, aluminum IgG1. And the magnitude of the immune globulin responses are shown here. So it seems to be, it's not such a big deal, okay? And that's what people think about it. It's not such a big deal. Then, however, if you look at the T cell responses, the surprises starts to pop up. And I will go in that one into more detail on CD4 and CD8 T cell responses, like here. Now, using IFA and CFA, okay? What you now see is suddenly that on side of the T cell responses, you see differences. IFA induces a strong IL-4 response antigen specifically, IL-5 response antigen specifically, CFA in interferon gamma 1. Okay, now, with other words, even though the proliferation, the total IgG was the same, the T cell response was differently influenced by the adjuvant. You got a Th2 immune response or a Th1 immune response, even though the IgG, total IgG was the same, okay? So it's very important to look at the T cell responses induced by the adjuvants and make sure the right class of type of immune T cell responses are induced by the adjuvant used. Then many people say, oh, okay, the adjuvant, no, the antigen will define, you know, and what type of immune responses on T cells you get. And in our hand, that was not the case. It didn't matter if Leishmania or schistosoma, NBP, BSC, Helvers, Heneglycosine, OVA was used, and what type of mouse strains, what background, so atopic or non-atopic mouse strains were used. All of them gave the same type of immune responses if they were immunized with the same adjuvants. So the adjuvants overrid the type of immune responder you are, atopic or non-atopic, as well as what type of antigen was used. So IFA, CFA, so it goes through the whole bank and you always get the same response. IFA in T cells induces IL-5 response, CFA and interferon gamma. So it goes through the whole time. Then the next comes, oh, it depends on your age. No. The age, we now looked at neonates and immunized neonatal because they were thought to be immune tolerant. Again, the adjuvant overrid it. So neonates immunized in IFA induced IL-5, CFA, interferon gamma. Adults, the same. So the immune response type induced is the same. So adjuvant is overriding all the background information. More interesting even is that when we did the defining which epitope is recognized. Even the same epitope was induced, however, with different cytokine profile. So here IL-5 with the same peptide dominating epitope than in CFA, okay? So adjuvant's influence on the T cell response is very dramatic. Now I'm going into tumor immunology and try to understand how, because protection against tumors is something we all want to achieve, and it is quite a tricky thing because tumors are immunologic similar to self, and they have tolerogenic mechanisms in place which we need to override. In the presentation, this is just the background. You will see all these tumors listed. PA15 is a mastocytoma, L5178YR will be referred in all my presentation throughout as LR and is a tumorigenic tumor. The sister clone LS, L5175-8YS, is non-tumorigenic. It's a clone of the tumorigenic one, then AMT6, B16 melanoma, and RMA. So this will be the tumor types I will discuss in my presentation. The first question which was addressed, are tumor immunogenic or not in mice? Looking at different readout, not proliferation, but looking at a different readout and with using the ELISpot. And if you inject a tumor into a mouse and you look at T cell induced immune responses, what you see is that all tumors are immunogenic and they produce strong IL-4. IL-4 is a tumor-prone cytokine which induces, their growth. So the tumor influences it, but it is immunogenic and it induces spontaneously IL-4. No interferon gamma, however. The sister tumor LS, however, which is non-tumorigenic, induces interferon gamma. Yes? And then if we look at if it's CD4 or CD8 T cell derived, what we found is that this IL-4, which we could measure in the tumor-bearing mice, is coming from the CD4 T cells, not from the CD8 T cells. The tumors injected mice bearing LS, which is non-tumorigenic, produced interferon gamma, and it was from the CD4 and CD8 T cell type. Then providing the non-tumorigenic cells first, and then thereafter following up with the tumorigenic cells, we actually could protect the mice. And from here, they are all protected. And it didn't matter. And that was showing that once an anti-tumor specific response is there, it is maintained and transferable and all of that. And it was CD4 and CD8 derived, and interferon gamma responses were induced. So looking at this high sensitive assay on a single cell level, we need to say that tumors are immunogenic, however not in a way which are against the tumor, but in a way that they promote the tumor growth. So the tumor made the immune response helping himself to grow, so which is not a good way, and we want to change that. The question came, can infectious surroundings change the impact of the tumor response? Which means is we use CpG as a type 1 adjuvant now, as a foreign product. And we let the tumor grow, and as the tumor grew, we injected CpG into the tumor, just the adjuvant, no antigen whatsoever, to see if infectious foreign product in a tumor surrounding, would it influence the T cell responses? And it did. The tumor actually was reverted and the mice cured themselves without any antigen-specific loading, just by injecting CpG into the tumor itself. This was transferable, It induced strong cytolytic T cell responses. It was CD4, CD8 derived, but we did not know what was the antigen. It was against the tumor itself. And each mice had different type of responses. We tried to then fine-tune it, but the response was there. It was transferable. They were protected. So if we transferred the T cells, we actually protected the animals with challenges with other tumor cells as well. If the mice which were not pre-injected, the tumor cell grew. So yes, you can generate T cell responses against the tumor just by changing the surrounding of the environment. That's one thing. But that's too uncontrolled, okay? We want to make it more controlled, so let's look at if we know and target an antigen, a tumor-specific antigen or peptide, and see if that can induce a T cell response against the tumor, and what type of immune response adjuvants can promote the anti-tumor responses. So again, we tested multiple adjuvants and their impact and how it changes the CD4 and CD8 environment responses to the tumor. So using H1.1 peptide, which is a 11-mer, it is a CD4 peptide, target cells looking at the diverse cytokine profiles to the tumor-specific antigen, the tumor non-specific antigen. So we used model antigens as well to compare the just adjuvant effect, to differentiate between the antigen-specific response against a tumor antigen and the adjuvant-induced protection. So what you see is that looking at these diverse cytokine profiles, CpG induced a very strong interferon gamma response against the tumor, but a peptide, which was part of the vaccine, but at the same time, a very strong response against the tumor itself, yes, RMA. So that was a peptide, a model now, which protected, which actually induced an anti-tumor response, not just against the peptide, but against the tumor itself. Non-CpG, the response as a control was lower, but still there, and CFA induced as well a good interferon gamma response, IFA, nothing. However, IL-2 was induced by all of them, IL-4 dominated by IFA, and IL-5 dominated by IFA and CpG. IL-6, that was an interesting cytokine. IL-6 and TNF. Now you need to dissect and look at the adjuvant-induced responses, because there seems to be a big adjuvant effect here. Because here the irrelevant antigen induced as well, if you look at that one, to the peptide, a very strong IL-6 in CpG, non-CpG nothing, CFA again high, IFA again low. And the same pattern was seen with the irrelevant antigen, which is adjuvant specific, not antigen specific. TNF, the same, that flip-flopped. So IL-6 was high to CpG, low to TNF. Non-CpG, IL-6 was low, TNF high. CFA, IL-6 high, TNF low. IFA, IL-6 low, TNF high, and the same pattern observed in the control antigens. Protection, if we looked at the irrelevant antigen, just the adjuvant effect, actually this is a good one. We saw an adjuvant-induced protection from 20 days to 30 days. Frequently this is shown as immune tumor protection, but this is now completely adjuvant-driven. And because the scale is this long, it's not as dominatingly shown as it could be, because the mice survived from 20 to 30 days just based on the adjuvant, not the antigen. When we added the antigen to it, then we had a survival of mice over 120 days of 40% or higher. And those mice, had very strong interferon gamma responses as shown, And now very important, what I want to highlight is the CD4 T cell responses and which cytokine is produced by which adjuvant. It seems to be that for CpG, CD4 responses are really strongly interferon gamma driven, and CFA, the frequency of the interferon gamma responses are lower. So this is the hierarchy of the interferon gamma produced responses and IL-2 responses by the diverse adjuvant. However, interferon gamma was the cytokine which protected the animal. I don't go over all the data that is in the publication where we use knockout mice to prove that point. So yes, tumors are immunogenic, and we need to change the immune profile which are naturally occurring against the tumor towards a protective one, and it seems to be that interferon gamma is one of the key cytokines to protect against tumors. Now, that was a tumor model. If we looked now another model for autoimmunity, which is again, is that true there as well? So we use PLP, we use the same type of adjuvants, we looked at the cytokine profiles, and what we saw was again that PLP induced strong interferon gamma, IL-2. However, surprisingly, CFA induced IL-17. In addition, and CFA induced DTH, and it made the mice sick. And they got autoimmune disease versus the CpG immunized animals did not get the disease. Meaning, even though they had the same interferon gamma amount in both types, interferon gamma alone did not. In this way, IL-17 was inducing the disease. If we added anti-IL-17, we could actually help the animal and cure them. So if we just look at interferon gamma by CD4 cells, CFA and CpG seem to be the same good. If you wish, they induce the same size of interferon gamma production. However, if we then look at other products and cytokine, then suddenly we see that CFA induces IL-17, EAE, and DTH, which is not a good idea for protection of the animals. So it was very important to look at other products beside interferon gamma to see what implication it has in the disease process. This was true for CD4 cells. Now let's look at CD8. Is CD8 and CD4 behaving the same way if you look at the same adjuvants? And if you look now, we used an CD8 peptide, UTY, looked at that, and we got a little bit of a surprise. The hierarchy changed. Now, CFA was the highest in interferon gamma production. CpG was much lower. So it was not such a good adjuvant for CD8 inducing interferon gamma responses. However, still it did some interferon gamma, some IL-2, and however, the same IL-17 which we saw from CD4 cells was as well induced by CD8 cells, okay, to CFA. However, that was not the protective part is cytolytic responses, killing. So let's look at killing. Now we looked at in vivo killing, and what we saw is that CpG, even though it was not such a good interferon gamma producer, induced very good in vivo killing. So it killed the cells, so the frequency is dropping here, which are of relevance, and the non-relevant one were not killed. And the same if we changed the antigen by the treatment, we saw the same picture. So we got very strong killing by CpG, but nothing by CFA. So again, if we would just look at if we want to immunize and look at CD8 responses, now just looking at interferon gamma and IL-2, you would say CpG is a lousy adjuvant for interferon gamma production or not as good for CD8 cells, and CFA is much better. But then if you look at the other products like IL-17 and cytotoxicity, it flip-flops. As not so good interferon gamma and a very strong cytotoxic CD8 T cell response was induced. This highlights that CD4 and CD8 cells have a different responses to the diverse adjuvants used. IgG is the same. You do not see any difference if you look at immunoglobulin classes, immunoglobulin types. So you need to look ahead of time what type of adjuvants you add your antigen into. Even though it's the same peptide, the same virus, the same vector, it will be changing the outcome in cellular responses. And this should be looked at when you select the adjuvant of your choice. If you look into humans, then they were immunized with dry vax and then challenged, not challenged, but blood taken, and in the assay looked at responses against vaccinia. What we saw is that granzyme cytolytic responses was seen at day 14 using the granzyme ELISpot, and later not. And interferon gamma, the memory cytokine profile, was seen over a long time period. So the timing for effector cytolytic T cell responses is very important to use the right kinetic and time point for it, as effector cells have a certain lifespan. They peak and go down, and interferon gamma frequency as well follow this classical pattern. But if you compare the long time to the basic, you see a nice increase of the memory T cell responses long term. And if we look at B cell responses, there we need to go as well into plasma B cells and memory B cell responses. The plasma B cells give you the possibility to look at antigen-specific responses directly in the blood and that's very important for pre-existing immune responses, because the ELISA, the memory response, is the same, but the plasma cell response will differ because that is induced by your vaccine. So you can measure directly plasma B cell responses from PBMCs to your antigen of interest and dissect with that one pre-existing to memory B cell responses. And here this is an ELISpot platform assay where we looked at antigen-specific, HCMV-specific B cell responses from cryopreserved PBMCs with the different classes of IgG, IgM, IgA, and you see they are all represented. If we look in the human population now, because we of course did not immunize for these antigens, what we see is that each individual has its own profile, even though the total immune globulin products are the same, but not the types. The types differ from person to person, and this of course can be used as well for in vitro killer assays or NK cell killer assays or neutralization assays as well. And with that one, I would like to thank you for your attention, and I just list all the people who participated in the papers which I have referenced, and take any questions to the data presented.
Because in the interest of the time, I'll just entertain one question.
Yes.
I would like to ask you for CD8, you showed that there are no correlate of protection with exception of cytotoxic assay.
I don't know if
there were no cytokines which somehow correlate with cytotoxicity.
I would not say that, because when I showed the first slide, where I showed the non-tumorogenic tumor, LS, there you had a very strong interferon gamma response induced by CD4s and CD8. It seems to be that interferon gamma plus cytolytic responses should be together to induce a protection. If you have interferon gamma alone, that is not sufficient. That's what I have shown you.
Yeah, but I think I'm talking about that CD8 response where interferon gamma was very low.
Correct. Interferon gamma was low. It was still 200 spots, so it is still good. Interferon gamma response was not as high as CPG. So it's not enough to just look at the height of an interferon gamma response, and that again shows the importance of taking the right assay, because I showed you as well the different assays have different sensitivities. So if you would have looked with ELISA for interferon gamma, everything would have been negative. Okay? However, because it was 200, whereas the other adjuvant CPGs, the interferon gamma response was above 500, so you could detect it with ELISA, so it would appear to be positive. So you would think only one produced interferon gamma, the other one did not. the one which produced high interferon gamma alone did not protect, versus the one which had so-called no or low interferon gamma had protection, because in addition to that it had cytolytic effector functions, which interferon gamma alone is not addressing. So interferon gamma alone is not a cytolytic cytokine readout. It's a pro-inflammatory cytokine readout, but not a cytolytic cytokine readout. And if you look in the literature, interferon gamma is used very frequently as only readout for cytolytic T-cell readout. And I think this is misleading. Yes, I 100% agree on that statement.
May I suggest that you two get together after the session and then have a long discussion?
Correct.
This is interesting.
Okay, thank you.
Thank you very